respect. Good questions. Tough ones. All right, first one, arc length. We're on a circle now. How to find the piece of the circle, the arc length. Here's what we're looking for here on number one. I want to get right after it. How long is HK? That piece there. How long is it? All right. So first formula for today to review, how to find arc length. Length of an arc. Actually, it's more than a couple formulas we'll need. It's going to be the measure of the arc over 360. I'm going to see if you guys can help me with the rest of that formula. We had a vocabulary term. I'll just show it on the diagram for two. What do we call the disc? Because perimeter, you can't have a perimeter of a circle. What's that distance around the circle called again? Vocab word. Circumference. That's what I need here. All right. I need the circumference formula, which was pi d. Okay, you're finding a part of the circumference. So do me a favor now, after you have that down, go to the back of your packet. And not only can you write the arc length formula down, you can also write the circumference formula down, pi d. So there should be two you can fill in. If you're still searching here, we're looking at 11 and 9. You can fill out 9 and 11 there. Anything that's been filled out by next Wednesday is fair game on the quiz as well. Anything we've filled out as a class is fair game next Wednesday on the quiz. Once you have 9 and 11 filled out, come on back to number 1. And let's finish this bad boy. Now, this measure of the arc, all right, the measure of the arc, that's got to be in degrees. So we're looking for how many degrees are in HK, and it's a quick circle fact. The degree measure always matches the angle. All right, so if this angle's 9 degrees, so is the arc, 9 degrees. All right, they always match. So 9 over 360 times pi, don't fall into the trap, right? Don't use 3,954. We want to double it because that's the radius. So we should be using, what do we got? 7,908. And you guys can crunch those numbers, and we're looking for nearest tenth of a mile when you have it. Keating, what's good?
621.1.
You got it. All right. Questions? Last one with arc length is, I'll give you the arc length. You solve for something on the right side now. Nice little circular track, of course. We are running A to S counterclockwise. So A to S counterclockwise. And that distance is 247. Okay, that distance, 247. What's the degree measure of that arc? That's a length of 247. That's what I'm looking for. How many degrees are in that arc right there? That's a distance of 247. All right, so where's the 247 going first? Here, let's talk 247, Keating in my formula.
Arc length.
Arc length, there it is. 247 equals. We're solving for the measure of the arc, so that's where my x is going to go. Over 360 pi. Diameter on that one, Zoe, what's the diameter length? 300, good. And now we're solving for x. Sometimes there's a pi on the other side, but there's no pi with the 247. So we can't just cross them out. We got to get rid of it another way. So I'm going to let you guys play around right now. You got to get rid of the 360, the 300, and the pi eventually. I don't care what order you do it in, but you have to get rid of them. All right, so get rid of the 360, the pi, and the 300 in whatever order you choose. And then we'll talk nearest degree. And I want to remind you of a hack too, in case you're nervous about solving this. And let me know when you're ready, nearest degree there. When you're ready, Jackson. 94 degrees. Just if you didn't get that, you got to multiply by 360 to get rid of it and divide by pi and 300. I told you, remember, quick hack. You can always go to equations and type that in. Okay, you can always go to equations and type that in. Good. All right, there's arc length. Can we go inside the circle and review how to find the area of a sector now? So let's go inside the circle, area of a sector. Your piece of pizza, your piece of pie, however you want to refer to it as, a sector. Same exact formula for arc length, except not circumference, area instead plugged in. Right, where we had circumference, we're going to plug in area. So measure of the arc again, over 360. But now instead of circumference, we're going pi r squared area. Once you have that down, go ahead, go to the back. And I believe now you can fill in 8 and 7 and 8. If it's not filled in already, 7 and 8. Bless you. All right, going back to number 3, when you have those two down, I'm telling you guys the area of this sector is already 12 pi. I found the area of it. All right, it's 12 pi. So we're going to substitute that in for area of a sector. Substitute that in for the area. We already know it. I'm not asking you to find it. What we are looking for is angle AOC. Not in the formula. That angle's not part of my formula, but remember the quick circle fact. That angle, that central angle, is always the same as that arc measure. They're always the same. So even though we're going to find the measure of the arc, we're finding that angle. Okay? Even though we're going to find the measure of the arc, we're finding that angle, AOC. And just be careful, we just did diameter with circumference. We're sticking with radius now, so keep the 6. See what's on both sides? Pi on both sides now, so you can get rid of it right now if you want. As long as I got 1-on-1, both sides. And go ahead and solve. And you'll see no rounding directions in the problem because none are needed. Keep crunching the numbers. When you're ready, let us know. Hayden, when you're ready.
Negative 8,600.
That's negative 8,000, huh? I don't think that's a possibility, huh? How you getting rid of the 360? Well, what are you doing first? Let me go there.
Got rid of the pi.
What's that?
I got rid of the pi.
On both sides?
Yeah.
So they canceled out, right? Then what?
And then I squished it like the 6 squared.
36, right?
Yeah, and then subtracted that.
Whoa. It's being multiplied. How do you want to get rid of it?
Divided.
Go ahead. Let's go. 12 over 36. And then how you getting rid of the 360?
Times 360.
Yep. Go ahead. All right. A little bit better than your negative space number there. Better. All good? One job. All right. One more sector one. That little piece there is 20. These arcs are congruent. We can put hash marks there. What's the area of sector BOD? All right, help me out here. What's the area of that sector? Well, it's something over 360. Can you find me how many degrees are in that angle? BOD? Because that's what I got to put on top of 360. I know what to do with the radius. That's easy. Talk to me here. How can I help me find that angle there? All right, Hayden, back to you, boss. We got this. If these arcs are congruent, so are the what? Yep. What do all three of these bad boys add up to? And you already have 20 and the other two are congruent. What do you got for the one I'm looking for?
80.
Yep. Done. Everyone see how we did that? 180 minus the 20 divided by 2. Pi. Hopefully everyone's using 6 again because the diameter was 12. I changed up the direction slightly. Just leave pi in your answer, which your calculator does for you, thankfully. Leave pi in your answer. Huh! Redemption. Let's go in. That's a 3-bagger, everybody, by the way, if you weren't missing. It knows. It's not random. That's crap. It's not random. It knows. It listens.
8 pi.
Here you go. It'll leave you alone now for a couple days. I heard that negative 8,000 and was like, oh boy, I got to come back to this guy. Questions? All right, we're done there with the area. Last thing I want to do with you, still in a circle, equation of a circle. All right, equation of a circle. So let's get it down first, put it in the back of our packet. Here's the equation of a circle. Did it a couple units ago. I'm not expecting you to remember. X minus h squared plus y minus k squared equals r squared. You can leave that under problem 5. Go back to your packet now and copy down the equation of a circle, but I want to make sure you know what each piece means in the back of your packet. So there's going to be a little bit more to write down in the back of your packet, please. You will have numbers plugged in for h and k. You will see numbers there. Those two numbers represent the x and y coordinate of the center of the circle. Okay, whatever numbers are plugged in for h and k, that's the x and the y coordinate of the center. And there will be one more number plugged in, and that's on the right side, r for radius length. But make sure you square it before you put it back in. All right, so those are the numbers that plugged in and what they mean. We got a problem, though, with number 5, don't we? It's asking us to put this into that form. All right, let's do it. Anybody remember the process from Algebra 1 called, how do I get it to look like the circle equation? You did it in Algebra 1. We reviewed it again. Completing the square. Here we go. First step to completing the square. Put the x's together, y's together, single number to the other side. Reorganize everything. Okay, reorganize everything in step 1. So x squared, what are we going to put with that bad boy? Net minus 2x, organize those together. And the same thing with the y's. Y squared and 6y. And the 3 goes to the other side by subtracting it. Now we'll complete the square twice, once for the x's, once for the y's. The x's have an a and a b value. We got to find a c value now for it. That's our job. Find the new c value. X squared minus 2x. All right, how do I find this new c value? Anybody want to chime in? Show off some greatness here. How did we find the new c value? That's part of it. Don't stop there. You take half your b value. Do that in your mind right now, everyone. Take half of that b value. Everyone got that number? Now square it afterwards. Square it. So you're taking half of negative 2 and squaring it, and you get positive 1. Okay, it should always be positive. Now do it for the y's, everyone. Do it for the y's. Y squared plus 6y. Take half the b value and square it. And you get your new c value. Half of 6 squared. 9. Key point right now, don't forget, it's unbalanced. You added 2 c values to the left. You got to add them to the right to keep this bad boy balanced. So make sure you add 1 and add 9. Add those c values. And one more step before we make it look like our circle equation. Factor. Or remember the hack. Factor or remember the hack here. 2 numbers that multiply to 1. Let me say that again. 2 numbers that multiply to 1, but add to negative 2. Multiply to 1, but add to negative 2. Negative 1, but what's the fancy way of writing that? Instead of x minus 1 times x minus 1, we can write x minus 1. Oh, now it's starting to look like something familiar. 2 numbers that multiply to 9, but add to 6. That should be the same. Multiply to 9, add to 6. 3 in. 3. Fancy way, y plus 3 squared. I mentioned a hack a minute ago. If you don't want to factor, that's fine. Take a look. All you're doing is always taking half your b value and getting that number inside. That's the quick hack. If you don't want to factor, take half the b value. And then over here, we're looking at, what do we got? 10 minus 3, 7. All right. It's just asking which one is the same. And it's going to be, let's see, minus and plus, choice 2. So knowing how to complete the square is a must. All right, I don't get sick often, but I'm going to throw up showing you this calculator hack coming up that I never showed you in the circle unit because I wanted you to learn this the right way. All right, here's the equation. What's the center and the radius? So for all you guys know right now, you got to take this, complete the darn square again. Breaking news. Your calculator can tell you what the center and radius is without doing any completing the square. This pains me. You remember my hack about finding slope and y-intercept? Same thing, except it'll tell you center and radius. So go to Grapher. Go ahead, go to Grapher. And type in this equation as is. You don't need to move anything. If something's in Grapher already, get rid of it. If you need the y, you go alpha 3. Equals 7. Enter, make sure it's highlighted. It'll tell you it's a circle. And then remember where we went for the slope and the y-intercept? 3 dots. Give me a little more detail, please. And this disgusts me. Look what's there. Okay. And even if you can't handle, maybe putting the x and the y together, they separate it for you there as well. Okay. This is awesome for a multiple choice question, but for like a part 2 question, you're going to have to show completing the square. Right? You just can't write down what the center and radius is without showing some work. And don't worry if you show some hot garbage and then all of a sudden magically come out with the right answer, you won't get credit either. And that's what the teachers look for when they grade it. What are we looking here? Choice 2. So look at that one, huh? Disgusts me that your calculator can do that. All right, final one. Here's the diameter. What's the equation of the circle? -4, 2. I just want to see what this looks like. That's the diameter, remember. That's one of the diameters in that circle. It's asking me for the equation, so I know the first thing I need is the center, right? Because the center needs to go into the equation. So now I turn it over to you folks. If that's the diameter, how can I locate where the center is? Or where is the center? It's in halfway, isn't it? It's right in the middle of that. The middle? So what am I going to need? Midpoint formula. There we go. I'm going to need the midpoint formula. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. And if you want, go ahead and go back to your formula sheet. And I believe that's number 2. Yep, number 2 is your midpoint formula on the back of your sheet there. And then I'll ask somebody what the midpoint is. Center will be in the middle of that diameter. Let me know what do you have for the center when you're done. After you plug those coordinates in the midpoint formula. Mia, what's good? 0, -1 looks good. All right, there's the center. The other piece I need for the circle equation is how long the radius is. How long the radius is, because I got to square it to put it in. So here's my center right there, 0, -1. I'll throw anything at me now. Throw anything. How can I find the length of the radius? I can use distance. All right, if you want, that's fine. Also, too, I just want to throw this out. You could find the distance from the center to A, center to B. They both work. Heck, you could find the distance of AB and cut it in half, right? Or if you don't want distance, we do have this little thing called Pythag. Right? You can say, oh, that's 1, 2, 3. That's 1, 2, 3, 4. And then find c squared there. All right, here you go. If you want to use distance, though, review a distance. X2 minus x1 all squared plus y2 minus y1 all squared. Or if you want to use Pythag, I just showed you there, you could use Pythag. But either way, I need to know what the radius length is from somebody. What do you got, Jonathan? Radius every
For diameter.
no,
10.
yeah, radius is 5. Yeah, I'm just putting distance here. Okay, 5 is the radius. All right, now let's use it in the formula. Don't write this down. I just want to remind everyone what the formula is. Okay, here we go. Center, 0, negative 1. So x minus 0 squared plus, what should go in the second parenthesis? Y, it's a negative 1. So when you plug it in, plus 1 squared. And then finish it off. What's going to go on the right side? My radius squared. Finish it off. Shoom, one more time. Jayla, finish this off. 25, 5 squared. If you want to have x squared here instead, that's fine as well. All right, get moving. 4 problems, it looks like there. 4 problems. Circles and sectors.